high-performing programmable networks with greater performance, more business flexibility, and lower total cost of ownership are here. Multipurpose networks are on the rise, and the one-size-fits-all model is dying a slow death. So if you run a network with thousands of different sites, then you need to manage those sites as efficiently as possible. Otherwise, it could be a nightmare. Different sites, different equipment, different configurations, information in all different places, Excel charts, different databases, and are they even up to date?
It is very difficult for our CSPs to understand what is there on the sites, and considering the sites are live entities, they are changing rapidly.
Every site is different. We have base stations on rooftops and towers of all different kinds, in many different kinds of terrain, with different frequency spectrum in each region. And we end up with unique combinations of radio bands in a particular location that's different than another location.
So we need to be able to ensure that all the time we have a clear understanding what is there on the field, how it operates, and how we can make it work better to serve our customers.
Today we have a logical representation of the network from the network management layer. Now, for the first time, we have a physical representation of the radio access sites within a network. What equipment is on site? Where is it physically positioned? How is it orientated? And where possible, how is it physically connected to the site? So we have that physical representation married to the logical representation of the network that they've never had before.
A multi-vendor digital twin that we can act upon and simulate for any kind of network activity. It can be network design, it can be network build, or it can be network operations. Before we even take the decision to go on the field. Now we have the ability to create a single source of truth of the entire network, no matter what type of vendors are providing the equipment for these sites.
So imagine managing 50,000 sites in the old way, manually, like she does. So complex, so difficult.
The different departments within a mobile operator may disagree on exactly what's out there at the site, and then they have to drive out there to see. Now, when you multiply that by 50,000 sites, imagine the chaos that can create. And if there's a single point of truth, that saves a lot of time back and forth within the operator's organization.
Everybody knows what's happening in the network, regardless of where they sit in an operator or an organization.
All the guesswork is removed, and even if there are risks, I know it beforehand, and I can act upon it before I even go and implement it on the network.
The bottom layer of the Ericsson Site Digital Twin is a mirror image of your entire network, a single source of truth.
Now, you can bring in the likes of AI, and you can say, okay, based on the data set I have, I can propose also that change to meet an end goal. And then as well as proposing it against the data set, I can also go and see the simulated effect of the data set as well. And you're doing it in a far more optimal manner than we would have done it in the past.
And where the second layer is actually like a playground, a place where you can test and train your network to do any business intent that you want.
You can't do that without an accurate representation and knowledge of what you have in place. You can't do it either without the ability to simulate changing services, changing the programmable network, and what kind of an impact it's going to have. Now we're providing the means and the foundation stones to do that.
Digital twins have been used by other industries for over 10 years, and admittedly the telecoms industry is a slow adopter. But things are changing.